Hey everyone, this will be a video about Chapter 3, which is on division for Math 112. So there are 6 primary objectives for Chapter 3. Compute quotients and remainders using the division algorithm, recognize the division algorithm and algorithms that compute only quotients and remainders, compute quotients and remainders of large numbers using a calculator, apply properties of the operation mod, apply the operation mod in real-world problems, and then apply the operation mod in the validation of ISBN numbers. So you might have noticed that we haven't really talked about division at all. Okay? And this chapter will be introducing that, and now we have talked about division after Chapter 3. So the first part, quotients and remainders, 3.1. How often does a natural number b go into another natural number a? So let's say if I had, at the bottom here, the exercise 30 divided by 7. Most of you probably will get your calculator, divide those, and then give me some decimal number. But before we do that, let's slowly think about this. So the answer to this question would be called the quotient of the division of A by B. So A divided by B will give me some value that we call the quotient. Okay? And this is usually denoted as a Q. Okay? Since we're only dealing with integers in this book, the quotient Q can only be seen as an integer. So you might remember a long time ago when you learned about division in elementary school, we didn't really have decimals then when we divided. So we had, quotients and remainders. Okay? So how can we figure out how often B will go into A? So if you think about it, the quotient is the number of times we will subtract B from A. Okay? So the quotient is the number of times we can subtract B from A. So you might wonder, if we're subtracting a number and we keep doing it over and over again, when are we going to stop? Right? So whatever is left over from A after subtracting B as often as possible is called the remainder. So what is left over after subtracting B as often as possible. Right? And you might wonder, well, what is that going to be? Okay, how often is often? Well, we'll get to that in a little bit, okay? So first thing we want to understand, we want to recall what a quotient was and what a remainder is. So let's look at this exercise that we have here. Okay? So let's say we have what is the quotient and remainder when 30 is divided by 7? Okay? So we had that for the quotient we have to figure out how many times can we subtract. Okay? So let's do some subtraction. So 30 minus 7 will give me a 23. Okay, then let's subtract it again. 23 minus 7 will give me a 16. Let's subtract it again. 16 minus 7 will give me what? A 9. And then 9 minus 7 will give me a 2. and then we're going to stop right here. Okay, so let me rearrange my video because it's a little... Okay, so let's start about that again. There was an issue that I had. So we did 30 minus 7 and got a 23. And then we're going to subtract again. So 23 minus 7 will give me a 16. We're going to subtract again. 16 minus 7 gives me a 9. And then 9 minus 7 will give me a 2. So if I think about this, well, what would my quotient be? What is left over? So we see what left over is the 2. So this will be your remainder. Because I can't really subtract again because I'll get a negative value. Well, how many times did I subtract? Well, this is the... Okay, so this is the first time, second, third, fourth. So I subtracted 4 times. So Q is going to be 4, and your remainder is 2. And you might think if you did 30 divided by 7 with long division, you'll get this result, okay? So if you want to think of division as doing long division from when we did it in elementary school, there we go. All right, so moving on. The division algorithm can be seen as the undoing of multiplication. Some might say it's the opposite. Okay, so recall that we said multiplication was repeated addition. So you can think of division as repeated what? Well, if it's the opposite, what's the opposite of addition? So we can think of division as repeated subtraction. Okay. You're like, oh, okay, well, if it's opposite, and I always remember this is an interesting way to think about it. So division is repeated subtraction. So, in the division algorithm, we start with a non-negative number a, and we want to subtract or keep subtracting a natural number b until we end up with a number less than b or greater than or equal to 0. Okay. Pretty much what that says, this part right here specifically, we're going to keep subtracting it, right? Until we get a number less than b and greater than or equal to 0. Which means if I subtract again b, I'm going to get a negative value, and I don't want that as my remainder. Okay. So you can take a moment here, and how would you classify as quotient and remainder? Okay. So I would just suggest use the definition we talked about earlier, that quotient is the number of times you can subtract b. And now for remainder, you can say, well, that's the amount we have left, and it has to be between. So just think now that with this part right here, we know that the remainder has to be less than b, but greater than or equal to 0. So it's very key here. Okay. So what about if a is less than b? Well, if a is less than b, if I subtract b, I can't do that because I'll get a negative value. So the quotient in this case would be 0. And the remainder would just be what a is. So if a is positive and a is less than b, quotient is 0, remainder is a. Okay, don't forget this. So you could think of this if you had 2 divided by 7, your quotient is 0 and your remainder would be a 2 because 2 is less than 7 and 2 is positive. Okay, so now let's move on to the next part. Let's talk about the algorithm because I know we all love algorithms from chapter 2. So here's the division algorithm for a positive value. So the input is a natural number. We see that our natural number is A, and our natural number is B. So we want to do A divided by B. And then you might wonder, well, why does the output have this weird formula here? How did we get that? Well, think about it. If, let's say, for instance, from the last example, we had 30 divided by 7. We got Q to be 4 and R to be 2. And what you can think of it is that the 30 is A and the 7 is B. So how could we go from B and Q and R to go back to A? Okay. So remember, if I subtracted 7 4 times, right, and that's how I could do the division, well then, if I want to figure out what A is, you can think, well, if I just do the B value times the Q, and then I add the remainder back in there, I should get what I started with A. Okay, and that's like an equation that will relate A to all of those. So you don't have to check this equation here. That's just stating that you need two values, Q and R, such that this equation is true. Okay. So you'll see the first step in the algorithm, it checks, is your A less than your B? If it is, then your quotient is going to be 0 and your remainder is A. So this is giving you a format of this is your Q, comma, this is your R. Okay. So what we do first is we assign Q to be 0. So we check that, and let's say if A is less than B, it's true. Then we're going to return 0, comma, A, and that's it. We're done. We don't have to do any of those other steps because we've returned. Okay? Remember, when you return in an algorithm, you get out of the algorithm. You don't have to do anything else. So let's say A is not less than B. Well, then we would go to step 2. So we would define Q, or the quotient, to be 0 at that point, and the remainder is A, assigned to be A. And then what's happened? Well, we're going to do A and B in the next step, and then after B, we check, is the remainder less than B? If it is, great. Then we would go to the next step, 6. But if it's not, what happens? We go back up to 4 and do A and B again in order, and then we check again at 5. And then if it's false, we go back up and keep doing it over and over again until we get that remainder to be less than B. Okay. So we have a question at the bottom here. Okay, so we see that for right here, what would it be like? So I'm going to scroll up a little bit. What would the output be? Okay, if A is 4 and B is 7. So for the first step here, I have to, so A is 4, so is 4 less than 7? This is true, right? So I am going to do what's after the then statement. So I'm going to return 0, comma A, which is 4. So that's what I see. And this tells me that my output would be 0, comma 4. So the quotient is 0. The remainder is 4. All right. The next part is A is 30 and B is 8. So we're going to do the one down here. Okay, so I'm going to write A and B up here, and then we'll scroll back up. So A is 30. B is 8. All right. So I'm going to scroll back up and write those back up here. So we said that A was 30. B is 8. So do the first step. Let's do number 1. Is 30 less than 8? Is this true? No, this is false. Okay, so what does that mean? Well, I'm not going to do the statement after the then here, because I only do that if the if part is true. So I go to step 2. So step 2 says Q is now 0 and R is now A. Okay, so Q would be equal to 0. R is now equal to A, which is 30. And then I'm going to repeat. So the first time through, it looks like R would be assigned as R minus B. So R is going to be 30, the current value of R, minus B, which is 8. So I get a 22. So currently R is 22. And then our Q would be the current value of Q, which is 0 plus 1. So we get 1. So Q is now 1. And then am I going to go back up and repeat this? So I look at the until statement. So R, which is 22, so is 22 less than B. B is 8. So this is false. Okay, so what I'm going to do is I'm going to go back up and do 4. Right, start at A again. So the second time through this loop, I'm going to do R is assigned as R minus B. So remember, R is currently 22. So R would be assigned as 22 minus B, which is 8. And this gives me, let me think. So let's get our calculator if we don't remember. So 22 minus 8 will yield me a 14. Okay. And now let's do what Q would be. Q is 1, the current value, plus 1, which would be a 2. And now I want to check that until statement. R, which is 14, is 14 less than 8. This is false. So what am I going to do? A third time through. So now we go back up to A again. So R would be assigned as 14 minus B, which is 8. And I get a 6. And then Q would be assigned as 2 plus 1, so I get a 3. And now let's check. Is R less than B? So R is 6, so it's R less than B. B is still 8. This is true. So now what I'm going to do, I'm going to go to step 6. Okay, step 6 says, I'll put a little step 6 here. It says return Q and R. So I'm going to return current value of Q, which is 3, and then the current value of R, which is 6. So it's very important that as you do these, you keep track of what you're doing and have very good notes to go through these. I noticed in some of the emails and homeworks I've got, if you do miss those things or if you forget the wrong value, it's going to be very detrimental, okay? But as you practice these, if you do have questions, please email me. So let's continue on. So what about if A is negative? What are we going to do here? So if you think, for this algorithm, if A is negative, well, A will always be less than B, so it's not going to have a quotient, and it's not going to have, and the remainder will be A. So you want to think, but that's not good, because the remainder has to be greater than or equal to 0 and less than B. So if it's negative, what do we need to make? We need to create a new algorithm. And you might think, oh no, I don't want to do this. Okay, but we have to. Okay, so we had to create this. So you want to think, if for a division of negative numbers, we're going to talk about that now. It's going to have a slightly different process. Okay, so recall that when A is positive, we wanted to find a Q such that this formula right here is true, and what also that's kind of cut off here is at 0, your remainder is greater than or equal to 0, and it's less than or equal to b. This needs to still be true for when a is negative. Okay. So instead of subtracting b from a each time, we're going to add it to a because a is already negative. Because if you think about it, if we keep subtracting it, but a is already negative, I'm never going to get my remainder to be in those values. Because remember, after I do my subtraction, I check my remainder. But now for when a is negative, I'm going to add b each time. And we're going to keep doing it until we get a value that's in between here. Remember, this is your remainder. It has to be between 0 and b, or equal to 0. So think about how this is different. So in the previous algorithm, you see that we subtracted b every time. So it makes you wonder, well, am I going to add b every time then? So let's see what the quotient and remainder would be. Okay. So for this one, I think I'm going to add it every time. So negative 33 plus 9 will give me a negative 24. Right? And then negative 24 plus 9 will give me a negative 15. Negative 15 plus 9 gives me a negative 6. Negative 6. Oops, let me erase this. Negative 6. Oop, gotta go back to my pencil. Negative 6 plus 9 will give me a 3. So you want to think, well, this is going to be my remainder. And how many times did I add? Once, twice, 3 times, 4. So it looks like maybe my quotient is 4 and my remainder is 3. But you want to think, if I check here, what would I get? So if we check 4 times b, which is 9, plus 3. Does this give me the negative 33? It doesn't. I get a 39. So we have to recall that since a is negative, and you think from previous, when we have a negative times a positive, in multiplication we get a negative value. Okay, so you might be wondering, oh, maybe this is the same for division. So when in division, when you have a negative divided by a positive, the output for this, or the quotient, is going to be negative. So we need to put a negative with the quotient here. And then if we put a negative here, this does work. Okay, you'll get negative 36 plus 3, which gives you the negative 33. So you want to think, when you're dividing, if a is positive, your quotient will be positive. If a is negative, your quotient will be negative. Okay, b will never be negative or positive. It'll never have a choice. B is always going to be positive for what we do in the book. Okay. So now that we've kind of seen this, let's think about how would we do an algorithm for division? Okay. And you'll notice this has almost the same amount of steps that the division for a positive number had, but we're missing one step at the very beginning. Okay. So you want to think, when you have a negative number divided by a positive number, you'll never have a quotient of 0. So we won't have to have a first step that we're going to check something and then get a quotient of 0 and a remainder of a. Because if a is always negative, you have to add something to that value first to get a positive number. So that's why. Okay. So let's look at the input here. So the input for this would be a negative integer a and natural number b. Okay. The output, 2 integers, we're going to say q and r, such that A equals B times Q plus R, and let me erase that. We don't have to have the equality there for the second one. R is less than B. Okay. So just remember, for the division algorithm, we're not going to check if A is less than B, because that's always true, and that won't really tell us anything. Okay. So the first step is let Q equal 0. All right. And then the second step is let R equal A, just like in the previous algorithm, except we're missing that first step of comparing A and B. And then what are we going to do? Well, we're going to repeat. So we're going to repeat. All right. So remember, in the last algorithm, we repeated R, we're subtracting B every time. Okay. And Q is increasing by 1. So you want to think, well, in this one, you kind of do the opposite. So we're going to add B every time. And you think, why? Because A is negative. And then for the quotient, we're going to minus 1 every time. So let R be assigned as R plus B. And then let Q be assigned as Q minus 1 until R is less than or equal to 0, and then we're going to return. Why do I have though? So before I do the return, I'll finish writing my return. Return the quotient and the remainder. Why do I stop when the remainder is positive? Okay, because remember, if A is negative and then R is a negative value for step 2 right here, I'm going to keep adding my B to that, which I'm doing right here in 3A. Okay, and then I'm going to check after I add it. If that remainder is positive, then I'm done. So then I need to stop. I don't want to keep adding it. Okay, so the only difference is from this one and the previous one is we're not checking A and B at the beginning. And then remember, instead of subtracting B every time, we add B, because remember, A is negative. Okay, and the quotient goes down by 1, not up by 1 every time. And the until statement has greater than or equal to 0. Okay. So, if you want more practice with this, you can use this algorithm. Okay, it's also listed in your notes in the book. And you could do this. So if you want more practice with understanding algorithms, you could do the output here for if A is negative 20 and B is 7. Okay. Or you could do it the first way we did it for a negative. You could keep adding 7. Right? So what I'll do is I'll use the algorithm for this. Okay. So we have A is negative 20 and B is 7. So we start out with at the very beginning. So we know that A is negative 20 and B is 7. So the first step says we set Q to be 0. So Q is equal to 0. And then R is assigned to be A, which is negative 20, because that's what A is. So the first time through my repeat, I say that R is assigned to be R, which is negative 20, plus B. B is 7. This gives me negative 13. And then my Q, which is assigned to be Q, which is 0, minus 1. I get minus 1. All right, so currently R is negative 13, Q is minus 1. So what am I going to do? I'm going to check my until statement. So is R greater than or equal to 0? So let me erase R, and R, remember, is negative 13. So is negative 13 greater than? Nope. So what am I going to do? I have to repeat again. I have to go back up to 3A. So second time through the loop. First step is R is assigned as R plus B. So that's negative 13 plus my B is 7. And that gives me a negative 6. And then Q is the current value of Q, which is negative 1, minus 1, which will give me negative 2. So I have a R value of -6 and a Q value of -2. I want to check. Is -6, your R, is that greater than or equal to 0? Remember, this is the until step. I'm checking. Is that a true statement? Nope. So what am I going to do? I'm going to go a third time through my loop. So R would be assigned as -6 plus 7, and I get a 1. And then Q would be assigned as -2 minus 1, and I get a -3. Okay, so if we think about it, so before we finish it up, let's check. So our R, which is the until statement part, so 1, is it greater than or equal to 0? And this is yes, it's a true. So what am I going to do? Well, the last step says I return Q, comma, R. So -3, comma, 1. So the quotient is -3, and the remainder is 1. So as I think, get used to these algorithms, practice more if you think you need to. All right, so for the given values of A and B, determine the quotient and the remainder for this inequality. So what all these are just asking you to do is determine what Q and R would be, and then rewrite the inequality with all the values plugged in. Okay. So you could, for all of these, you could practice. So I would suggest practicing these on the side. How did you get the Q? How did you not? Okay, so for the first one, we see that, well, 7 is not less than B, right? So A is not less than B, so I know I'm going to have a quotient because A is positive and bigger than B. So 7 minus 3 is 4, and then 4 minus 3 is a 1. So I know this part is your remainder, and I did it twice here. Right? So that would be your quotient. So Q would be 2, R would be 1. So if I rewrite my inequality, it would be 7 equals B times Q plus R. So 3 times Q, which is 2, plus 1, which is R. And that's how you would set these up. So for part 2, you might wonder, well, can I subtract 8 from 7? Well, I can't, because 7 is smaller than 8. Remember, when A is positive and less than B, you won't have a quotient. And the remainder is just A. So for this one, the quotient would be 0, and the remainder would be 7. So let's set this up. So it would be A, which is 7, equal to, parentheses, B, which is 8, times Q, which is 0, plus 7. Okay. For the next one, 20 divided by 4, you might think, oh, that goes in nicely. Okay, so then the quotient is just 5. And what I mean by it divides nicely, it goes in nicely, there is no remainder. So now if I write this inequality, I see that I'll have A, which is 20, equals B times Q. So parentheses 4 times 5, plus my remainder, which is 0. Okay. And for the last one here, we would have to, since A is negative, we'd have to add that. Okay. So how many times would I have to add it? So I would practice this one, and if you actually did add your B, you would add it 5 times. But remember, if you add it 5 times, the quotient isn't negative because, the quotient isn't positive. Remember, when A is negative, the quotient is negative. So here, your Q would be -5, your R would be 2. So practice this one. Make sure you can get -5 for Q, and your remainder would be 2. So then if I wrote it as an inequality, -13 equals 3 times Q, which is -5, plus 2. And for those of you, if you want to see the addition for number 4, just think you would do negative 13 plus 3 and you would get negative 10. Negative 10 plus 3 and you would get negative 7. Negative 7 plus 3 and you would get negative 4. Negative 4 plus 3 and you would get negative 1. Negative 1 plus 3 and you would get 2. So I did this how many times? All right, so 1, 2, 3, 4, 5. So that's why the quotient is 5, but it's negative because a is negative, and what's left is my 2. Okay. So we're going to talk about a few theorems now. All right, so let a be an integer and b be a natural number. Then there exist unique integers q and r, with r being between 0 and b, including 0, such that this is true. So this is now true for any value of a. So another way to denote the quotient of the division of a by b is div a div b. And another way to denote the remainder of the division of a by b is a mod b. So in mathematics, a shortcut or a shorthand notation for if someone wants the quotient of two numbers, they just say the first number that's going to be divided by the second number, the first number div the second number. And if they want the remainder, the first number mod the second number. Okay? So let's practice. Okay? So you want to think, if we make a note just up here, div is asking for quotient. Mod is asking for remainder. So on your test, if you see 4 div 7, what does that want? Well, that wants the quotient if I have 4 divided by 7, which can't happen. I can't divide 4 by 7. Now I'll get a remainder, but I won't get a quotient. Quotient will be 0. So 4 mod 7 will be 4. Okay. 30 divided by 8. So we can look back earlier. I don't know. So what did we get here? So we got this goes in 3 times with the remainder 6. So then the div would be 3, and the mod would be 6. And then up top, we just did 20 div 7 and 20 mod 7 because we did 20 divided by 7 and got quotient would be negative 3. So that's the div, and the mod is 1. So think div is quotient, mod is remainder. All right. So let's continue on to the next part. So the next part is long division with a calculator. Look at this wonderful smiley face that I have. So suppose you want to divide 300 by 16, and you had to use long division. So remember, we're calling this from elementary school. So 16 divided into 300. So it doesn't go into 3, but it goes into 30. So one time, we get a 16. I subtract these two, get 14, bring down my 0. And then 16 into 140, the lowest is 128, which is 8 times. So I get 12. And then you want to think, from this, what can I say? Well, this is my Q, and this is my R, right? So this is very tedious, and you have to be extremely meticulous. Like if you forget a number or multiplying correctly, what's going to happen? You're going to mess up your calculations after that, which sucks. Okay? So we have a shortcut for this. We're going to talk about long division with a calculator. So let's look at these steps, and they're kind of broken up. So first thing you do is you want to think, we want to find a div b and a mod b, and we set up a long division problem to do that. So the numbering is a little off here, so technically this is like not a step. It's like what we want to do. So first we compute a divided by b with a calculator, and then we want to think about, so I'm going to start doing the next exercise on here, and then I'll write it again for everyone. So the next exercise is 300 divided by 16. Okay. So first thing, I want to compute A divided by B with a calculator. So 300 divided by 16 with a calculator gives me 300 divided by 16. I get 18.75. So this is like the second step here. So what about the third step? It says the quotient Q would be the biggest integer that is less than or equal to the number on your calculator screen. Well, this is the number on my calculator screen. The biggest number that is less than or equal to this is actually 18. So when you see less than or equal to, think about left of on number line. This is very important, especially if, let's say, your division was negative, okay? So we know that's 18, and we're going to place that on top of our long division. So we'll do that on the next page. Okay. So the second step that we had said that we do 300 divided by 16, and this is 18.75. And you want to think, the largest number to left of 18.75 is 18. Oh, let me write that 18. It looks horrible. Is 18. Okay. So now that we have that, it said in step 3 to write it on top of the long division. So 16 divide into 300. I'm going to write 18 at the very top. Okay. So now it says take B. So remember, this is your B here. Right. This is your B. And remember, this is now your Q. So take B and Q and multiply them together. So if I do 16 times 18, I'll get what value? 16 times 18 with my calculator, 288. Right? So I put that under A. So remember, here's A. So I'm going to place that value, 288, under A, 288. And then it says step 5. So I did 4 right now. Step 5, I subtract the 2. So I'm going to subtract and I get 12. And it says that what I get is the remainder in step 5, right? Well, after the subtraction, I'm going to get my R here. Wow, so that is just what I got from doing long division the long way. This is the shortcut, okay? So we're going to practice one more problem this way. There are a few homework problems using this sort of way. Okay. All right, so let's do this negative 457 divided by 24 using this long division with a calculator. So remember, so off to the side here, we're going to write 24 divided into negative 457. So first thing is the step, like the second step that's listed on the previous page. We divide it with a calculator. So negative 457 divided by 24 gives us on the calculator, dun, 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 if we, let me see. So make sure when you do negatives, you do the calculator perfectly. So double check that you can do this with your calculator. I get negative 19.0416 dot, dot, dot. So you'll notice that, well, what's the largest number that's less than or equal to this? And you might think, it might be negative 19. But remember, this is a negative number. So on the number line, we have negative 19. And here's that value, right? And here's negative 20, and negative 18's over here somewhere. That, what number is to the left? Oh, it's negative 20. So this is the one that we would pick as that Q. Okay? So for my Q, I'm going to use negative 20, because that is less than or equal to the negative 19.06. Okay, so then remember, so this is like part 3, okay? Remember, you're thinking, once you get that number, think of a number line. The number to the left would be the largest number that is less than or equal to. All right, so remember the fourth step was we do B times Q. So this is B is 24. Q is the quotient we got, which is negative 20. We multiply those and we get negative 480. So I put that, remember, I put that under my A, and then I'm going to subtract these two. So with my calculator, I'm going to do negative 457 minus negative 480. What do I get? A positive 23. So this is my remainder, and my negative 20 is my quotient. So this algorithm you can do for A being positive or negative. Okay, so we just have a few more sections to go over. So as I said, the previous one, the long division with the calculator, when A is negative and you get that negative Q, you're going to have to think, if you think of a number line, what number is to the left? That's the number you want for Q. Okay, so if we continue on, we see that in the next part, we're going to talk about a section for the operation mod. And you might wonder, what about the operation div? Well, it's not as important. Mod is a lot more interesting, okay? So the 3 methods so far that you can think of the operation, what has been mod used for? Remember, mod means remainder. We want the remainder, okay? So one method is that you can just look and get the mod from 2 numbers, like 7 divided by 6. The mod would be 1. That's by the trained eye. The other one is by using the long division with the calculator. We could get the remainder. And the other one is using a division algorithm. Remember the repeated subtraction. Okay, so remainders have a characteristic called wraparound. So you might wonder, what does this mean? Okay. So let's look at the following example and we can kind of see what that means. So if we walk through here, if someone asks you to fill out this chart, 0 mod 3 is going to be 0, because that's the remainder. 1 mod 3 would be 1. 2 mod 3 would be 2. Okay, because all those are less than 3. So let's look at the next ones. What would be 3 mod 3? That would be, well, 3 can divide into 3, so the remainder is 0. What about 4 divided by 3? Well, the remainder would be 1. 5 divided by 3, the remainder would be 2. And then what about 6 divided by 3? The remainder is 0. Oh, and 7 divided by 3 is 1, and 8 divided by 3 is 2. It looks like there's a pattern. So this is what they call the wraparound effect, kind of. So, you see there's a pattern here. What's this pattern? It's 0, and then 1, and then 2, and then 0, and then 1, and then 2, and then 0, and then 1, and then 2, and then it keeps going. So you'll notice, well, that's interesting, because if you think about it, if you divide any number by 3, the remainder either has to be 0, that 3 goes into that number, or 1, or 2. If the remainder was 3, then I didn't really divide it all the way, okay? So this is really true for anything that you do mod of a certain value. So if I did mod 5, the possible numbers I could get out for the remainder would be 0, 1, 2, 3, or 4. Okay, so this is kind of we're kind of noticing, do we see a pattern? And we do. Okay, so what do we get? Let's talk about now. So these 2 definitions here. So if n is even, then if you do that number, mod 2, you get 0. Okay. here. That should make sense. If I divide a number by 2 and it goes into it nicely, with the mod being 0, then it's even. And if it doesn't, I'm going to have 1 left over as my remainder. So remember those two definitions. So let's now look at a theorem. We have two integers, a and b is a natural number. If I have a plus b mod m, this equals a mod m plus b mod m, and then after that value you get, you take the mod m again. And you're like, whoa, way too many mods. I mean, that is kind of true here, but this is a theorem. We're not going to prove this theorem, okay, but we're going to utilize this theorem. So, first we're going to do one approach, which is I'm not going to use this theorem. I'm just going to add the two numbers together. So in a lot of cases, you can do that. But if you didn't know what a or b was, then you can't add a and b together. But in this case, I do. So I'm going to go through both approaches. All right. So let's say I have 10 plus 20. That is going to be 30. So the first approach is I just add the numbers together. So I get 30 mod 7. And you want to think, what is 30 mod 7? What's the remainder from 30 divided by 7? Well, that's going to be, 7 goes into 30 4 times. What's left? I get a 2. Okay. So you want to think, if you're still struggling with doing mod, you can always think we just did you can do the division algorithm. You can keep subtracting 7. Okay. Now let's do the other approach. So you want to think our A is 10, our B is 20, and our M is 7. So it'd be double parentheses, 10 mod 7, close parentheses, plus 20 mod 7, close parentheses, mod 7. So now let's simplify this piece, and let's simplify this piece. So 10 mod 7, what would be the remainder? That would be 3 plus, what's 20 mod 7? How many times does 20 can you get divided by 7? That's twice. With what left over? A 6. So this would be a 6 here. Mod 7. So now let's add these numbers together, and we get that that's 9 mod 7. And then 9 divided by 7, what will be left over? It'll be 2. And we see, oh, look, they're the same. Yeah. So this theorem looks like it does work for this example. Okay. So let's see an example where we don't have this. Okay. What if we don't know A and B? Okay. So let's look at the next example that we have here. Let's say A and B are integers, and A mod 13 is 29, and B mod 113 is 100. What is A plus B mod 113? You can't see the 113, though. So I'm looking for A plus B mod 113. Well, I'm just going to use the theorem we just talked about, right? So remember, this would equal, parentheses, double parentheses here, A mod 113 plus parentheses B mod 113, close parentheses twice, mod 113. And you might think, what should I do? Well, don't I know this value? It's stated to me, right? Right up here. What about this value? Oh, look, it's stated here. So the A mod 113 will be replaced with a 29 for the whole thing, plus 100 for the second piece, mod 113. And now I'm just going to simplify it. So I get 129 mod 113. And then what would I get for the mod? So practice this for a second. Try to do the calculation. And what would we get? We would get a 16. Right? So that would be your answer. So you see, this is how you would use this theorem if you didn't know A and B. Okay? So let's continue on. The next theorem we see, it looks very similar, but what do you notice? Oh, there's a multiplication here instead of a division. Instead of an addition. Remember that multiplication is repeated addition. So we can use that here. Okay. So we're going to do 10 times 20 mod 7. We're going to do the first approach again, and then we are going to do it with the formula approach. So 10 times 20 will be 200. So it'll be 200 mod, so 200 mod 7. And then you want to think, so practice this. What would the remainder be when you divide 200 by 7? This is very good. You could do the long division approach or the algorithm. Or you could subtract 7 and keep doing it until you get the first number that's below, remember your b, or in this case 7, and you would get a 4. So what would be the second approach? Using the theorem that's stated above here. So this is our A, this is our B, this is our M. So double parentheses, 10 mod 7, close parentheses, times 20 mod 7, double parentheses there, mod 7. So 10 mod 7, that would be a 3. 20 mod 7, we did in the previous example, that would be a 6. And then 3 times 6 is 18 mod 7. I think that was going to give me a 4 as my remainder. So you want to think. You could go through the example again and practice, but you want to make sure you understand how to get the mod. Okay, that's just thinking, what's the remainder? If you divided these two numbers, what would you have left? Okay, so for this last one here, how would you compute this? All right, so you want to think, well, I'll probably just multiply them and then add. You could do that, okay? So that's one approach. So if we do that, we see that this would be 61 plus 72 mod 7. Okay. And what would we get here? So 61, I think I said 62, but I meant 61. 61 plus 72, it gives us 133 mod 7. And then this will yield us in the end the remainder of 1. Okay. All right, we had a short brief pause there. So let's go over this problem just one more time. So if we do 61 here plus the 72 mod 7, that will give me the 133 mod 7, which actually will divide nicely. So the remainder, I think it said earlier, would be 1. Actually, it's 0. That was my mistake. Okay, so practice this. If you wanted to do this problem using the two theorems, you could do that as well. Okay, and you want to think, you should get 0 if you want to do it that way. So let's continue on to the next part. Suppose if we have 8,082 mod 17 is 7, and 4,540 mod 17 is 1, what would be the product of the two mod 17? Then you might wonder, well, let me just key in this product on my calculator. 8,082 times 4,000. I get a really large value. And how would I do mod 17? I could do long division, but that's a lot of work. And with larger numbers, you might make a mistake. So we could use the theorem here. We could say, remember, this is your A, this is your B, and this is like your M. So double parentheses, 8,082, if I could write this, 8. Let me just erase this. This looks awful. Right? 8,082 mod 17. times 4,540 mod 17, close parentheses twice, mod 17. So I know that this is given to me, it's actually a 7, times this is given to me, it's actually 1. So then 7 times 1 is 7, so 7 mod 17 would actually be a 7. Okay. So you want to think, there are a lot of ways to handle these more difficult problems using some of these theorems, and this way is one of them. Okay. So let's look at this next one. You might think, wow, this is a really long number. If only this was my bank account statement, right? So you want to think, I'm not going to try to say this number. That's too many numbers for me to say right now. But how would I do mod 20 of this? And you might think, if I think of those two theorems, maybe somehow I can do where I rewrite this as an addition. Okay. So if you think about mod 20, what would 20 go into? 40, 60, 80, 100? Maybe I can rewrite this long number I have here in terms of something times 100, or I have two single zeros, that means 100 can go into that. Okay, so I'm going to rewrite this as 2,2,3,8,2,9,1,3,3,4,6,0,0,8,0,2,3,4,0,0 plus 71 parentheses mod 20. You might wonder, why did I separate this way? Remember, I'm rewriting this number as a sum of two different numbers. So suppose if you're looking at like $130, you could write that as 100 plus 30. So that's what I'm doing. I'm taking those ones and tens out and putting two zeros there. And now I'm going to apply that theorem. So I have that really long number, 1,3,3,4,6,0,0,8,0,2,3,4,0,0 mod 20 plus 71 mod 20, close parentheses, mod 20. And then I can think, what is this going to be, this first part here? Well, I know that's going to be 0 because it's divisible by 100 because it has those two places there, those two zeros at the end. Okay, so I can say that this is 0, and then 71 mod 20. Well, if I calculate what the remainder is, I get 11. So that would be plus 11, and then mod 20. What's this is 11 mod 20, and then, we see that our A part, remember our 11, which is we usually say is A, is less than our B, which is 20, so the remainder will be 11. Okay. So now what should we do now? That's it. So we did the first two examples here. So the video is rather long, so we're going to try to get through the last two sections, the clock arithmetic and the ISBN applications. Okay. So let's go on to the next section. So applications, one of them is with mod, as you saw the objective at the very beginning, real world applications. So one is the clock arithmetic. So applications with the combinations of the operations mod and the addition of integers are called clock arithmetic. A clock has how many hours labeled on it? It's going to have 12, right? And then so if you think about a clock, that the image is in your book, if you go around, it's like you're repeating. You do 1, 2, 3, 4 all the way to 12, and then 1, 2, 3, 4 all the way to 12, and then 1, 2, 3, 4 all the way to 12, and so forth. So remember, what did we learn earlier that had patterns to it? It was the mod operation. Okay. And you want to think, well, mod had 0 to a certain number. So in this case, instead of thinking of 12 as 12, we're going to think of 12 as 0. So you can look at a picture in your book to help you with that. It is on page 62 of your book, okay? So how could we find how many hours, if it's 10 hours from 11? So currently we're at 11, right? We're going to add 10 hours to it, and then we're going to do mod 12. So if we do that, we don't have to do those theorems. We can just add the numbers. So 21 mod 12 would be 9. Okay. So that would be at what? At 9 o'clock, right? Okay. And then the second part says, what about if we're 25 hours from 11? So take a moment. What would you add to 11 if you want to be 25 hours from it? You want to add 25. So for this one, it'd be 11 plus 25 mod 12. And you want to think, what's 11 plus 25? This would be 36 mod 12. And this would give you actually 0. So remember, what goes with 0? Actually, it's 12 o'clock, so it would be 12 o'clock for this. Okay? So if you get 0 when you do this, that means it's the same time. So for this, it would be the same time as 12. Because 12 o'clock will go with 0. So let's practice. What time is it in 79 hours if it is 4 o'clock right now? So we're starting at 4. And what are we going to add to that? How many hours in the future do we want? We want 79. So we're going to add 79, and then we're going to do mod. Since we're dealing with the clock, it'd be 12. So this would be 83 mod 12, and then you want to think, what would this value be? So you could practice a little bit. It would be 11. So this would be 11 o'clock. So when you want to know how many hours in the future you're going to have, or what time it would be, think mod 12 if you're reading the clock for these problems. For the next few ones, it says, which day of the week is it in 110 days if today is Friday? Well, this will be a little different. So Friday is not really a number, so we're not going to add anything to Friday, but we're going to use the value we get and then count from Friday. So if I want to know 110 days, well, I'm not going to do mod 12. How many days are in the week? So if you think about it, that would be 7. So I would do 110 mod 7, and that's going to give me, so practice for a moment. You could pause the video. What would you get? You would actually get 5. So this is 5 days from Friday, which is what? So if we're at Friday, we have Saturday, we have Sunday, we have Monday, we have Tuesday, we have Wednesday. So 1, 2, 3, 4, 4, okay, 5. So Wednesday would be the day we want. Okay? That would be 110 days from today if today is Friday. So if we look at the next one, which month is it in 721 months from now if this month is November? So if you think in a year, how many months do we have? Well, we have 12. So we're going to take this 721, and what are we going to do? We are going to do mod 12. Okay. So if you practice with long division, or you could do the algorithm, you should get 1. Right, so that means it's 1 month from November, you could think. So that would be December. Okay. So these are some of the clock arithmetic problems you would have. So we just have one more section to cover, the final stretch for chapter 3, which is ISBNs. So, and this formula for ISBNs will be given to you on your test, okay? So don't stress about studying for this. It will be stated in the problem if it's on your test. So an ISBN is a 10-digit number that uniquely identifies a book. So each digit on the ISBN, as you see labeled here, okay? Each digit, so first digit, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, will have a value from 0 to 9, and the 10th digit might also have the value of 10, but remember, a digit can only be one thing, not two. 10 is two numbers. So that if it's a 10, you'll notice I said it's an X, and that's to the side here in your notes. Okay, the 10th digit can take the value 0 to 9, and if the value of 10 is labeled as X. Okay, labeled as X right here. So to figure out if a valid ISBN, so if these digits form a valid ISBN, the 10th digit would equal this equation here, which is 1 times the first digit, plus 2 times the second digit, plus 3 times the third digit, plus 4 times the fourth digit, plus 5 times the fifth, plus 6 times the sixth, plus 7 times the seventh, plus 8 times the eighth digit, plus 9 times the ninth digit, mod 11. So remember, when you do mod 11, what's going to happen? You can get any value from 0 to 10, and if you get 10, remember, that means you need to see an X for that 10th digit for it to be a valid ISBN. Okay? So if you got some other number, then the ISBN is not valid. So the 10th digit is like checking to make sure it works. So let's practice a problem with this. Suppose, is this a valid ISBN? Okay, so what I like to do for this problem is I like to label my digit. Okay, so I'm going to label my digit. Alright, so this is with 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is the 10th one, right? So I'm going to multiply each one of those, the first 9 to its place value, and then add them up, do mod 11, and if I get 3, because remember, the 10th digit is 3, and if I get 3 after I do the mod 11, then this is a valid ISBN. If you don't, then it is not. Okay? So, let's write out this formula and see what we should have. Okay. So, we have the first one, which is the first digit times the value of that digit, plus 2 times 3, plus the 3 times the third digit, plus 4 times the fourth digit, plus 5 times the fifth digit, which is 4, plus 6 times the sixth digit, which is 5, plus 7 times the seventh digit, which is 3, plus 8 times the eighth digit, which is 7, plus 9 times the fourth digit. And then we have to do mod 11. So you could do a lot of things for this. You could do the theorems if you wanted to. I prefer just to multiply each number and then get a big sum in my calculator and then do long division to get the remainder. So if I do the multiplication, 0 plus 6 plus 12 plus 20 plus 20 plus 30 plus 21 plus 56 plus 36 mod 11. Okay, so if I add these together, I'll get 201 mod 11. And now you can either practice. I would practice getting the remainder, whichever method you prefer. But in the end, you should get 3. And it just so happens 3 is the 10th digit. So this is also 10th digit. So because it's the same as the 10th digit, it's a valid ISBN. Okay. So I hope you enjoyed this video. Please, as you're going through your homework and stuff, if you do have questions, shoot me an email. I'll be more than happy to help you. As always, thanks again.